So hello friends, in this video we are going to discuss our Leetcode Biweekly contest 137. Okay, so basically let's discuss our first problem statement. Our first problem is find the power of k subarrays part 1. Okay, you are given an array of integer nums of length n and a positive integer k. Means you have been basically given a, array of integer. Okay, array of integer called nums. Like this array of integer you have been given over it. And basically a positive integer k. A power of an array is defined as a if its maximum element, if all of its elements are consecutive and sorted in ascending order. Okay. So basically, uh, let's discuss it with the help of an example. Let's discuss it. What is meant by the power of an element? Power of an element means the maximum highest order of the element, and the element must be in ascending order. Okay, and it must be in consecutive. Okay, what are consecutive numbers? Let's discuss. Consecutive numbers are 1, 2, 3, 4, or we can say 9, 10, 11. Consecutive numbers are numbers whose absolute difference is 1. Okay, whose absolute difference is 1 means 9 and 10 is consecutive. 9 minus 10, its absolute difference is 1. 10 minus 9, its absolute difference is 1. Okay, then 11 minus 10 is 1. Okay, then 12 minus 11 is 1. So means consecutive numbers are the numbers which are coming one after the other, and the distance between them is only simply 1. Okay, so basically these are the consecutive numbers, and they must be in what? Ascending order. Okay, they must be in ascending order. Let's see a pair over here. Basically, uh, 2, 9, 11. This is what in ascending order over here. The pair we have been given is in ascending order. But is it a consecutive number? No, it is not a consecutive number. Means not a pair of a consecutive number, because the difference between 2 and 9 is 7 and 9 and 11 is 2. It must be basically what? 1 in both the cases. In both the cases it must be 1. But the difference here over is 7 and 2. So basically it's not a consecutive number. So the pair is not valid in this case. In this case, the pair is not valid, and our answer over here will be -1. Okay, so now you need to find the power of all subarrays of nums of size k. Okay, return an integer array result of size n minus k plus 1, where results of I is the power of nums. Okay, so basically, our result array, we have to return a result array whose size will be what? Whose size will be n minus k plus 1. Its size is basically n minus k plus 1 over here. Okay, so let's see our first example. In this case, basically our first example is uh, 1 2 3 4 3 to 5. Okay, our nums given to us is what? 1 2 3 4 and 3 to 5. 3 2 5. And basically your k is what? K is 3. K is now let's see what is the use of k over here. K is basically the size of the subarrays. Means this 1 2 3 2 3 4 3 4 3. Okay, means the subarray size must be of the length 3 over here. Okay. So basically if k is 4, then what? If k is 4, then the subarrays will be what? Let's see. Then the subarrays will be, if k is 4 over here. Okay. If k is 4, then our subarrays will be 1 2 3 4. Okay, then 2 3 4 3. Okay, means the sub-arrays will be of length 4 over here. Okay, if k is equals to 4. So let's move forward. So let's see our first sub-array. Let's see our first sub-array. It's 1 2 3. Okay, it's basically 1 2 3. As you are able to see that the nums of j plus 1, uh, nums of j I am considering by using a for loop over here. Let's see. Basically, this is my first number and this is my second number. Okay. First of all, we will see that if the nums of j, we can say, or we can say our first number, if our first number plus 1 equals to the second number, then it is basically consecutive. Okay. If our first number means 1 plus 1 equals to 2. Okay. Means this number plus 1, if it equals to this number, okay, if it equals to this number, then it is a consecutive. Then we will see 2 plus 1. We will add 2 plus 1. If it is equals to a 3, then it is a consecutive number. Okay. So in this case, basically our ascending order and also our consecutiveness both are checked over here. Okay. So let's see the finite approach over here by solving this problem statement. How many subarrays in this problem we are getting? We are getting 1, 2, 3. Okay. Then 2, 3, 4. Then 3, 4, 3. Okay, let's discuss the three ones. Basically, the absolute difference of all the number in this is 1. Okay, means all are consecutive. So basically, we have to return the maximum element. So in this, 3 is the maximum. So our answer will be 3. In this, 4 will be our answer because the elements are consecutive. But in this, basically, the 3 plus 1 is equals to 4. But 4 plus 1 is not equals to what 3 over here. Okay. So basically, this is not a consecutive subarray, and our result over here will be minus 1. Okay. So our next subarray is what? Our next subarray is 432. Our next subarray is basically 432 over here. So let's see. Basically, 4 plus 1 is not equals to what 3 over here in this case. So basically, it's not a consecutive subarray. So our result in this will be what? Minus 1. Okay, so our next now our last subarray. Last subarray is what? 3, 2, 5. So basically in this also 3 plus 1 is what not equals to 2. So basically it's not also a consecutive subarray. So result will be what? Minus 1. So basically our answer will be, our result will be 3, 4, minus 1 and minus 1. Okay, so basically this will be a result in this case. So basically, let's see what kind of approach we are going to use. We are using a simple brute force approach. Okay, we are going to use a simple brute force approach in this case. We are going to use a simple brute force approach. Okay, so now let's see that how we will be able to solve the problem. First of all, let's see what will be the size of our result. Our size of the result will be n minus k plus 1. Okay, keep in mind our size of the result will be n minus k plus 1. So now let's discuss. First of all, let's initialize our n as what? N as our length of our nums. N as our length of our nums and our result. Our result will be what? Minus 1 multiply n minus k plus 1. Minus 1 multiply n minus k plus 1. Okay, so basically, let's consider a simple example over here. This example only 1, 2, 3, 4. 4. Okay, 1, 2, 3, 4, 3. Let's make it short and more precise. I am writing here an example of nums equals to what? 1, 2, 3, 4, 3. And our k is what? K is basically equals to 3 over here. Okay. So, here our n, here our basically n will be what? N will be the length of our nums array. Our length of the nums array is what? 5 in this case. And result will be what? Result will be n minus k plus 1. N is what? 5. 5 minus k. 5 minus 3 equals to 2. 2 plus 1, 3. So result subarray will be of size 3. Okay. Our result subarray is of size 3 now. Okay. So basically, what will be doing now? Basically, I have initialized my result subarray. Okay. Result array. Then we will iterate. Okay. Then we will iterate for each element in the nums array. Okay. So basically, our example is what? Our example is 1, 2, 3, 4, 3. Okay. And our k is equals to basically what? K is equals to 3 means we have to form a subarray of 3 elements. Okay. We have to form a subarray of 3 elements. So how we will do this? How we will going to achieve this 3 element subarray? So basically, we are going to simply run the for loop in range of n minus k plus 1. Okay, in n range of n minus k plus 1. So basically for I in range what n minus k plus 1. I will be running this for loop in this order. Let me show you my code. Okay. So basically I will be running my for loop in range of n minus k plus 1. Okay. Means here my n minus k plus 1 is what? My n minus k plus 1 is basically 3 over here. Okay. It is basically 3 in this case. So now let's move forward. Then I will be initializing my is consecutive to true. Okay. My consecutive we can say is initialized to true over here. And my maximum value is what? Nums of I. My maximum value is nums of I over here. Okay. So now I will be running a iterating a for loop from I to I plus k minus 1. Okay. I will be iterating a for loop from I to I plus k minus 1. Let's see. Basically our I is from 0 to k I plus k minus 1 means 0 plus k. K is 3. 3 minus 1 means our second for loop will be 0 to 2 means j will be equals to 0 to 2. So means 0, 1 and 2. Okay, so we have got a subarray of 3 size in this case. Okay, so let's move forward. Then I will be checking that nums of j plus 1 is not equals to nums of j plus 1. Means what does it mean? Nums of j plus 1 must be equals if it not equals to nums of j plus 1. What does it mean? For example, if we have been given an subarray like 3, 4, 3. Here my nums of j is what? Its indexing is 0, 1 and 2. If for j is what? 0. If for j is 0, so nums of 0 is what? 3. So 3 plus 1 is what? 4. Is it not equals to nums of j plus 1? J is 1 over here. With 0 plus 1 is 1. If it is not equals to 4, means its next element. We will initialize our is consecutive to false. Okay. Now let's see if my j is what? 1 over here. If my j is 1, so nums of 1 will be over here, which will be 4. Nums of 1 will be 4. And nums of j plus 1 will be 2. Okay. So it will be 3 over here. So basically, if my here my 5 is not equals to what 3 over here. My 5 is basically not equals to 3. So my consecutive will be what? My consecutive will be false in this case. And we will break over here. And our result will be in this case what? Our result will be minus 1. Okay. our result in this case will be what? It will be simply -1. So basically, then I am initializing my nums of j plus 1. Nums of j plus 1 is the last value. Okay. If, for example, you have been given a consecutive array 1, 2, 3. So this is what my nums of j plus 1. Okay. So basically this, if it is greater than my maximum value, I have initialized my max value to this. Okay. If 3 is greater than 2, so my max value will be now this. This will be my max value, and it will not be my max value no more. Okay. So basically, at last I have checked that if my consecutive is true, I am initializing the max value to the result, and else if my consecutive is false, I am initializing the result with -1. Okay. Let's check for each iteration over here. Okay. Let's check for each iteration. So basically, over here, let's see. My example was what? My example was simply, okay, 2, 4, 3 means 1, 2, 3, 4, 3. Okay. Here my example was 1, 2, 3, 4, and 3. Okay, and simply my k is equals to 3. So basically, let's run through each loop. Here my n is 5, and result, let's suppose r, it will be -1, and -1. Okay, so basically, my first subarray means I equals to what? 0. For I equals to 0, my nums of 0. My nums of 0 over here plus 1 is equals to what? Nums of 1. Okay, means 1 plus 1 is equals to 2 over here. Okay, so means which is true over here, and my nums of 1 is greater than max value. It is true, and my nums of 1 is greater than what? Max value. Okay, so basically it will be 2 greater than 1, which is our max will be what? 2 over here. Okay, so in this way we will be just simply moving forward and iterating through each loop. Okay, so at last we will get our result simply as what? Our result will be simply, let's see, 1, 2, 3. Okay, so basically at last our simple result will be 1, 2, 3, which is what? 3. Then 2, 3, 4, which is basically 4. Okay, then we get 3, 4, 3, which is -1 because it's not a consecutive over here. So our result will be simply 3, 4, -1. Okay. So this was for the our first problem statement over here, basically. Now let's move on to our second problem statement. Basically, the problem is same over here, but just the difference is in the constraints. Okay, differences in the constraint. If you run this code, if you run my this code over here in this question, you will simply get a TLE. So we have to solve this problem statement by sliding windows. We have to just solve this problem by sliding windows approach. Okay, so let's see what is the sliding window. Basically, let's see. This is my indexing over here 0, 1, 2, 3, 4, 1, 2, 5, 6, 7. Okay, so in sliding window, what happens? You are checking for each k. If your k is what? 3 over here, so you are checking for each k. So your first k will first sub array will be 1 to 5. So we'll be checking the condition for 1 to 5. Okay, and then And then after checking the condition for 1 to 5, we will move on to 2, 5, 6. Means just move forward. Wait a minute. Okay. Just move forward over here. Okay. Then after checking its condition, you will be again moving forward. Again, simply move forward. Okay. So in this is basically the sliding window approach. Okay. Means your window will be just moving forward one by one rather than creating different windows. Okay, rather than creating different sub arrays, we can say in brute force approach we create different sub arrays. So basically, their time complexity will be what O of n square. But here our time complexity will be O of n only. Okay, sliding window. Let's see. So basically, let's see my initialization over here. Let's see my initialization in this case. Okay. So basically, I have create our nums, then I have created a ARR of -1 into n minus k plus 1. Okay. As you know, in the first problem statement we discussed. Then I have created a k1. Okay. Over here, I have created a k1 over here. Okay. Which is an index used to place the result in ARR. It is an index used to place the result in ARR. Okay. So basically, our left over there. What is the left? Left is basically the starting index of the current sliding window. The starting index of current sliding window. Okay. And is consecutive basically over here checks for the condition if our nums is what if our sub array we can say is consecutive or not. Then for then we process the iteration over here. Okay. So basically the this is basically sliding window loop we can say the sliding window loop we can say. This is basically the sliding window loop. The right boundary of the sliding window means iterate from 0 to n minus 1. Okay, so basically for each I we will be checking means we will check if the current element breaks the consecutiveness. This is for checking the condition if the current element breaks the consecutiveness means the window has more than one element. Okay, so basically this is used to check that means if we are be checking that if our right is not equals to right of -1 if the current element is not consecutive with the previous element. So our consecutive is set to false. Means what I mean to say, this is given and you are at this position. So basically, your nums of right, we can say, your nums of right is what? 2 over here. Okay. 2 is not equals to what? 2 is not equals to nums of right minus 1. Nums of right minus 1 plus 1. If it is not equals, right minus 1 is what? Right is basically, oh, as you are able to see, right is basically 1. So 1 minus 1 is 0. Nums of 0. Nums of 0 plus 1 means 1 plus 1 over there. 1 plus 1. It is basically 2. So basically 2 is what equals to 2. So it is consecutive in this case. So that was used to check the condition. Then I will be checking that if my right minus left plus 1 is equal to k means it is used for checking if the window has grown to the desired size k. Okay, check the check if the window has grown to the desired size k has grown to the desired size k. Okay, so basically we will be checking that if our subarray is consecutive, we will be just means if our subarray is consecutive, we will be storing the last element of the subarray in ARR of K1. store the last element in ARR, or we can say it is the maximum element. You can say we are storing the maximum max element. Okay. So basically, if our means subarray is not consecutive in this case, our ARR of K1 will be what -1. Okay, as you know, we'll be incrementing our K1 by 1 for each iteration one by one. Then next, then we will be adjusting the means we will be adjusting the sliding window. Okay, adjust the sliding window. Okay, so basically, if my left plus 1 is less than n, and our nums of left plus 1 is not equal to nums of left plus 1. Okay, so means before shifting the window, now check the if the leftmost element of the nums of left, okay, was maintaining consecutiveness with the next element. Let's see. Let's understand why this. Okay, means what does this means? My left plus 1. Suppose we have been given 3, 4, 3. Okay, and my nums of left is what 4. So 4 plus 1 is what 4 plus 1 is basically 5. So my 5 is not equals to what nums of left plus 1 means left plus 1 is 2. We can say it is index 1, 1 plus 1 is 2. Okay, so is not equals to what 3. So in this case or is consecutive is initialized to true. Okay, and if our left plus 1 is less than n. Okay, so we will be running a for loop from left plus 1 to right. We will be checking if our nums of I plus 1 is not equals to nums of I plus 1. So our, if it is not equal, our consecutive will be false over there, and we will simply break and increment our left and return our simple the array. Okay. So this was the explanation for our problem statement. Let's understand the, let's do the dry run. Okay. Let's do the dry run. Basically, you've been given 1, 2, 3, 5, 6. Okay. And k is what 3. So in this case, our left is what 0 and right is also 2. Means this is iteration 1. Iteration 1. Left 0, right 2. Okay. So it will be 1, 2, 3 in this case. So basically our consecutiveness is yes. It is yes consecutive. So basically store in ARR, 3 in ARR. We will be just storing 3 in the ARR. Okay. Then iteration 2. Simpler the iteration 2. Our left is 1 and right is what 3. Means 2, 3, 5. So it is basically not consecutive. So we'll be storing -1 in the ARR. Okay. Then move forward to iteration number 3. Basically our left is 2 and right is 4. Okay. Means 3, 5, 6. Basically it is also not consecutive. So we'll be storing -1 in the ARR. Iteration we are appending the values and the maximum of it. 1, 2, 3, 5, 6. Okay. We have been done with all the values over here. Basically now we will just append 3 minus 1 minus 1. Okay. So this is our answer 3 minus 1 comma minus 1. This will be our final output in this case. Okay. So basically this was all for the today's weekly contest, bi-weekly contest. So thank you friends. If you have any of the doubt, you can ask me in the comment section.